So, hello again. Welcome to all the people to this first live chat that we are organizing from the eGHOST project. I will begin with a short presentation of the project and the activities we are performing here about the eco-designing of hydrogen products. Then, after that, the floor will be open and all your micros will be connected. And I hope that we can have a nice talk, a nice exchange of opinions on this. So let's start. The eGHOST project, as you can see, is, sorry, do you see my screen now?
Yes.
Yes?
Yes.
Yes, okay. So, as you can see, the eGHOST project is a European project where we have several partners here in the energies coordinating this project, and we have the very valuable contribution of the CEA in France, the University of Ljubljana in Slovenia, the Fundación Hidrogen Aragón, also here in Spain, Sambio, it's a company from France, and the IAE is an institute for energy technology in Japan. So, and the project is funded by the joint undertaking in fuel cells high. So the specific goals of eGHOST is to develop the first eco-design guidelines for hydrogen system, concretely for two products. One, as we will see later, one is related to a PEM fuel cell, and the second one is a solid oxide electrolyzer stack. But we want to go one step beyond what is the classical eco-designing. We talk in this project about sustainable oriented design because we will include here different measures to improve the performance of the product, not only from an environmental point of view, but also including the social performance of the product along the lifespan of the product and, of course, along the value chain of this product. So the methodology that we are using here, we are during these first years, since the project began on the past January, we have performed the social life cycle assessment and also the environmental and economic ones to determine the main drawbacks and the different aspects of these two products from these three perspectives, the social, environmental, and economic. And all the knowledge gained here will be applied to develop a new product following the typical eco-design methodology. So the next steps in this eco-design is just the proposal of new product ideas to improve the performance along the life cycle of these products. And we, just to address all the important aspects in the value chain, we are following the typical eco-design strategy wheel you can see on the right side of the slide. And we are addressing different aspects, so to improve the product at the component level and the structure level and then the system level. So we are, sorry, in this slide you can see the two products that we are eco-designing or designing with a sustainable perspective. The first one is the PEM fuel cell stack for this power, 48 kilowatts, and is defined from industrial data. And the second one is the solid oxide electrolyzer stack for 5 kilowatts, as you can see in the picture. As commented in this first year, we have been developing the different life cycle studies to determine the most important aspects. We have studied the environmental, you can see the life cycle assessment. On the other side, we have the social results and also the costing of the different components and different materials. And we have identified the the main things to be, or the main issues to be improved. For instance, unexpected platinum has a very important impact, not only in the environmental side, but also including the social part, especially as you can see in child labor or in forced labor, and of course for salary. But we have also identified also other components to improve it, as it could be the bipolar or the plate, and also the aspects of the carbonaceous compounds, especially important from a social perspective. So that was all from my side. As commented, the idea here is just to open up the floor and to have a real conversation, a real talk about what we are doing. And now, if I can, the floor is open. I will connect the micros for all the people. Please go ahead. I think that I cannot activate the micros for the people. Marta, could you help me, because I cannot activate the micros of
Yes,
the.
I'm on it. I think it's activated. They just have to activate their micros individually if they wanna speak.
Okay. So please.
Let me check. 1 second. Yeah, it's supposed to be activated. So if anyone wants to start, just turn on your micro.
No questions?
Just a sec. Supposed to here. Sorry about the inconveniences. Just a second. In the meantime, if you want to speak, you can raise your hand and we'll activate your micro individually while we are sorting out this technical problem, sorry.
Es que lo tienen quitado de ellos.
Felipe is raising the hand. I will try.
Okay. Sabina, for example, has turned on her micro, Lara as well.
Okay,
There it is.
so.
Can you hear me?
Yes,
Please go
very
ahead.
well.
Okay, perfect. Okay, so thank you, Javier, for this presentation. Hello, everybody. I'm Sabina from Environment Park. We are involved in Best4I project. That is a project with approach in end of life recovery. The main components, platinum, nickel from PEM fuel cell and solid oxide fuel cell. We also we will have a dedicated work package that will work also on eco design. And we will cooperate together with you also on this aspect. I hope. And I have just a question related to the eco design. So I think that there is the need to have a strict cooperation in eco design, and so in the harmonization in the fuel cell hydrogen fabrication process between the fuel cell manufacturers and also the recyclers. If we imagine to recover just some parts from these components, how do you think this collaboration can be established, and which are the main agreements that are needed in order to promote the eco design?
Okay, thanks, Sabina. Yeah, it's really important to have the contribution of manufacturers and recyclers in the redesigning of these hydrogen products, because the idea is to make a new design to ease the collection of the waste parts or the separation of the different parts at the end of the life of the product. Actually, in the methodology that we are following in this project, one of the important stages to be taken into account is the end of life and how to make easier the disassembly and also the recycling of the different components. The ideal solution to this will be the incorporation of a recycling expert in our eco-design sessions. And as you know, we are trying to solve all the administrative issues to incorporate you in our project, and we can participate also in our project. And I hope that both projects, your projects for High and eGHOST, can have a very deep collaboration. So I think that your role as recyclers in the eco-design is basically key to reach real useful new designs in the future.
Okay, so yes, what we will also we will manage during the project is also the involvement, as you also suggest, and also you will perform with the main regulatory stakeholders, also standardization entities that we imagine to involve, and I think that we can cooperate to connect with them and also involving them in a dedicated workshops, asking them to help us in this aspect.
Yes, in our advisory group also we have a company for specializing in the standards and standardization. So they also will contribute to, let me say it that way, to standardize the final guidelines for eco-design.
Okay,
and I think
perfect.
that it will be very important to have this kind of standardization included here, just to recommend all this to the industry how to redesign these new products. Okay, more questions? I think that Felipe, I think you have to unmute yourself.
Stefano, hi. You've got your micro on. Hello.
Yeah. Hello, this is Stefano from Rina Consulting. We are part of the Best for I project as well. I have a question. You know, in Best for I, we are targeting, let's say we are the leader of the work package related to eco-design. So it's important for us, of course, to make a synergy with eGHOST. But I have a question, because in your project, you are targeting, as I understood, the realization of an eco-design guideline for a PEM fuel cell and a solid oxide electrolyzer. My question is, would it be possible somehow to interconnect these two guidelines? The point is, of course, towards solid oxide fuel cell coming from the, let's say, the merge of the two, and to PEM electrolyzer. This is my question. What is your feeling to make a more general guideline?
According to my experience in other fields, I think it's better to keep separated two technologies. Of course, solid oxide electrolyzer or solid oxide fuel cell will be very similar because there are just very few components different. It is the case for PEM electrolyzers and PEM fuel cells. But in this moment, I think that it's better not to mix the both technologies, because there are some specific questions for specific aspects for each technology. In any case, also in eGHOST project, our final outcome here will be a white book with a general recommendation for eco-designing different hydrogen systems. including storage and other kind of technologies.
Thank you for this. The guidebook will be very relevant for us, for sure.
Yeah, I think that we have to collaborate. We are working on that. You know that many static issues are very, very long and they are taking a very long time, but I think that I'm seeing the light at the end of the tunnel. So I think that in the next month, we will solve all and we can sign this collaboration agreement to collaborate. And your collaboration will be more than welcome to our eco-designing workshops. More questions?
If no other question, I have another on this. So, which are the main indicators that a fuel cell manufacturer must evaluate and take into account, thinking on the eco design aspect?
Of course, for the manufacturer, economic issues are very relevant, of course, but it should be linked also to this environmental performance. For instance, global warming potential indicator is a must, but also I think that criticality indicators are very important here, for instance. And of course, we can look for other specific indicators. In the case of Spain, for instance, the water footprint is also very relevant here. So we can have several general indicators, criticality, global warming potential, and so on. But I think depending on the location of the company or the manufacturing plant, it's also we have considered also other indicators. And I'm very sure that the social impacts should be taken into account, or must be, more than so this must be or have to be taken into account in the new designs to avoid mistakes that we have seen in the past from other fields, as people working in slavery conditions, child labor, and so on. I think that we now that the hydrogen economy is starting out, and we can say that it's exploding because hydrogen is everywhere. I think that now is the moment to ensure that the hydrogen economy will be socially responsible. So I think that the European sector should be conscious of these kind of indicators and has to redesign the supply chains according to this. More questions? I don't know, Diego and Manuel, I see your cameras are on. I don't know, you want to comment something?
Yeah, I have a question. I don't know if you guys can hear me now. Yes?
Yes.
Okay. Yeah, you mentioned in your presentation, Javier, that platinum arises as the main hotspot under pretty much every environmental indicator. Which are the other, I mean, are there any other materials that could be maybe subject to these eco-design measures? For example, what are your thoughts on Nafion, for example, the polymer that is used in frames?
Yeah, thank you, Pepe. You're right. You're right. Nafion now is under the vision in the European Commission and in the United States due to the very important problems of this material. Nafion is very persistent and this is an advantage, but this is also a drawback because its recovery or its elimination is very difficult, and even the compounds derived from the destruction are very pollutant. So this is a pending question. The problem here is that the hydrogen manufacturing sector depends a lot on platinum and Nafion because the PEM technology is based on here. I know that the hydrogen sector is looking for alternative materials, but there is not a clear solution in the next year. So we have to look how to improve the performance of these two materials. For instance, we are sure that reducing the amount of platinum is a must, but also we need to increase the amount of recycled platinum coming back to the hydrogen manufacturing sector. Or for instance, in Nafion, we have to develop good recycling technologies. For this, the best material is what is that that is not used, and then we can recycle and reuse this, and Nafion it should be a very good alternative. So, more questions? We have half an hour still to comment here to talk about the hydrogen and eco-design.
As Javier said, the link also with the Best for High project for technology. So we have this relevance not only for the platinum, also for the membrane and the ionomer. So at that point, novel technologies are needed and will be promoted, let's say, in the guidelines for eco-design. And novel technologies recovering both catalysts and membranes. We know that they are being proposed, but mainly at the laboratory level or not close to the market. I don't know if maybe Best for High partners have more information, but for sure in the eco-design message. So we have just started the brainstorming sessions. We have already held one for the pen fuel cell product, the pen fuel cell stack, and one of the keys that we have found, one of the foci of the brainstorming was also this need for acting on the recovery of platinum and the recovery of the membrane, and also developing further these technologies that can recover both key products.
Yeah, I want just to add a comment on this. So yes, Best for I will study and evaluate and also perform these recycling processes that I think are useful also for you in the eco-design. And also we will evaluate the recovery of the ionomer. So also via probably an alcohol dissolution. We are starting not as an environment part, but our partner as Recycling is starting now this evaluation in order to optimize the process of recovery of this material. And we have also in the advisory board a company that is working on this membrane preparation processes. So we think, yes, that this approach will help the eco-design and also eGHOST project.
Okay, and it will be good then to orientate the design of the device to make easier the extraction of the membrane then, and to facilitate also the second process from here.
This is key because in this way we can avoid the incineration of the membrane. That is the phase where the hazardous pollutants would arise. So these are good news and would be fully aligned with a redesign of the products.
So, any other comment or curiosity?
Hi, do you hear me?
Yes.
Hi. I would like to know if you could maybe further explain how are critical materials included in the evaluation, and also for best for height partners. I have a question regarding these critical materials. So, are you studying end of life, specific end of life treatments for critical raw materials included in hydrogen systems?
Yes, from the eGHOST project, and we have incorporated this criticality in the life cycle assessment of the products, because you know criticality is a key factor now in the European Commission as to avoid or to decrease the use of this kind of materials. So this indicator has served us to identify this kind of material, the components with these materials, and looking to, we have to look how to decrease the impact with this criticality indicator.
And yeah, I related to best for I, yes, we will evaluate the recovery of critical raw materials, and also, as I said before, precious materials such as platinum and ionomer, but also nickel and yttria stabilized zirconia from the solid oxide fuel cell. And yes, we will perform along the project an LCA and LCC study in order to manage all these aspects.
Yeah, a comment on the solid oxide technology. I think that this is more challenging than the PEM technology, because for PEM there are some technologies at different levels for this recycling, and we can also look for technologies from other sectors, for instance, for platinum recovery. But the problem with solid oxide is that, at least up to me, there is not a clear technology for the recovery. So this is a challenge for eGHOST and for Best for High project, just, and I think that it could be a good contribution to the hydrogen field, just to propose to make initial insights on how to deal with this aspect of solid oxide technologies. So more comments, more questions. Perhaps the partner of eGHOST would like to add something to.
Hello, Javier. I'm Dario Cortés from Argo Heavy Foundation. I have a question related with other stages of the assembly of the fuel cells, for example, the supply chain, because we have talked until now about the critical raw materials, but as far as I know, all the components of the fuel cells are not produced or manufactured into the same site, and all that components are transported to a central site where the final fuel cell are assembled. So I would like to know what could be the impact of this supply chain compared with the extractions of the raw materials.
Thanks, Dario, for the question. I think that the contribution of the manufacturers in the first stage of the supply chain will have a very deep impact in the final performance of the product. So the idea is that the final manufacturer, final importer of the different components could influence or can influence the suppliers just to improve the overall performance of the product. So in this very first market of hydrogen, that I think the most important issue is just to introduce in the market the products and to make them familiar to people. This could be a secondary aspect, but we have to keep this in mind that, okay, we need to disseminate or to make popular the hydrogen economy in the society, but this popularity also depends in the environmental and social performance. So then I think that what we reach in the eGHOST project will not be applicable in 2 years or 3 years, but it will be applicable in the midterm. We're just looking at 5-10 years time. I don't know if any other partner could add something here, because this is a very important question. Is how can we influence on the different actors of the supply chain?
I think this is Diego. I think this is also related, could be partly related to the end of life. That's promoting recycling. As you know, this can improve even the security in terms of availability of the resources. So, and this would also encourage that the supply chain is not very dependent on other countries. This is also, for instance, critical for platinum, that if it comes mainly from South Africa, and it will continue in this way, but reducing this dependence on virgin materials, it will be, I think it will be also an additional point promoting national business around fuel cells and hydrogen products.
Thanks, Diego. Any other contribution? Any other comment?
As Emmanuel Koch from CA speaking, I just wanted to add that so I'm working at CA as a life cycle assessment and eco-innovation expert, and we are contributing in the project, and we are really glad to be a part of this project. Notably in the definition of the reference product for the life cycle sustainability assessment. The difficulty we have actually in our RTO that is developing new technology for energy is really to support them to integrate environmental and sustainability aspects day to day in their R&D development. So we can maybe ask ourselves in the context of this project of how the eco-design guidelines will support this activity at day-to-day life, and how we can make it usable by technical experts. And I think it's a real stake of this project to be sure that it will be correctly and really used by technical experts, and not only life cycle experts or environmental experts.
Thanks, Manuel. You're right. We need the contribution, also the technical experts here to ensure that we will have a useful guideline. More comments? So, if not, I think that we can close here this chat. We will have another chat in the future. We can inform on more details about the new design of these two products. So, thanks to everyone for attending this live chat, and also to all my partners in the project. So thank you. Bye bye. If there is not any other comment or other question. No.
Thank you for the presentation.
Thank you. Sorry, I didn't hear.
Yes, thank you for the presentations, Emmanuel said.
Okay, so sorry, Emmanuel, I didn't hear. So thanks again. Bye bye, and hopefully see you in the next live chat. Bye bye.
Thank you.
Bye.
Thank you. Bye.
Thank you,
Bye.
Thanks.
Javier.
Bye bye.
Thank you.
Bye.
Bye.
Thank you. Bye.